Hi, everyone. Welcome to today's webinar, 911 Technology for Non-Engineers, How the Magic Happens. This training is brought to you by Commercial Electronics. If you would like to learn more about commercial electronics and our reporting solution and third-party quality assurance services, visit commelectronics.com. This webinar is part of our Public Safety Education series, and you can view our upcoming webinars on our training page at commelectronics.com/training. Before we get started, I'd like to go over a few housekeeping items so you know how to participate in today's event. Here you see a screenshot of the attendee interface. You should see something that looks like this on your own computer desktop. If you're listening in using your computer's speaker system, you're automatically muted to eliminate background noise. If you would prefer to join over the phone, just select the handset in the audio pane at the bottom right, and the dial-in information will be displayed. You'll have the opportunity to submit questions about today's lesson by typing your questions into the Q&A pane of the control panel. You can send in your questions at any time during the presentation, and I'll address them during the Q&A session at the end of the presentation. So the best time to send in your questions is when you think of them. And remember, I'm not an engineer, so I make no promises of being able to answer your questions. Once you leave today's webinar, you'll receive a survey on the presentation. And we would appreciate it if you would complete that and let us know how we did so we can continue to provide you with relevant content. You'll also receive a follow-up email within 48 hours with a link to view a recording of today's webinar. For those wanting to report this training to their state certification or licensing agency, send an email to training@commelectronics.com. My name is Beth English, and I'm your instructor today. I began my career as a police dispatcher 31 years ago. I was very young, and most recently served as a communications director before joining Commercial Electronics as the program manager for their QA/QI program and higher ground instructor. I have my master's telecommunicator license from Texas. I'm a TCOL instructor and a past president of Texas NENA. That's all I have to say about that. So let's get started with our session. Let me begin by telling you now that this is going to be a very basic lesson with small words. I'm not a technical person, I don't understand electricity, and I don't do math. So if you're here for a high-powered discussion, you're in the wrong place. Please exit stage left. For the rest of us, if you've worked in 911 for more than an hour, you know there are thousands of acronyms being tossed around. You're told what they stand for, but not necessarily what they mean or what their function is. You know that citizens are calling in on 911 and on the admin lines, but you don't know how the telephone knows the difference in order to send the call to the right line. Also, how does the phone system know that the 911 call should come to you as opposed to another agency in another city in another state? Well, the best way to learn this is to start at the beginning and build on it as you go. And that's what we're going to do. In the beginning, communication was accomplished by the use of drum beats or smoke signals. Then came the telegraph, which worked by sending signals using electric currents and magnets that pointed to the letters of the alphabet. Samuel Morse later developed the Morse code, which most of us have heard of, and that was a method of dots and dashes to indicate letters in order to move messages more quickly across the wires. And this is what was used until Alexander Graham Bell invented the telephone, again, based on electrical currents. You've probably heard someone mention analog at one time or another. Analog telephone lines transmit your voice as electrical signals in a range from 30 hertz to 3,300 hertz or 3 megahertz. The microphone in the telephone converts the sound from your voice into electrical waves, which travel down copper wires until they reach the other end, at which time the speaker in the phone converts the electrical signals back into sound waves. And just in case you're wondering, a hertz is a unit of frequency. And that's as technical as I'm getting here because I had to look that up to tell you that. Now, the first telephones were directly connected from one customer's location to another customer's location. But as more customers were added, that method became impractical. So the telephone company established manually operated switchboards. Initially, these were installed in the operator's home, so customers could have 24-hour calling. But eventually, they were moved to central offices or COs downtown. With the invention of the switchboard, customers who subscribed to the company's communication service would be connected directly to the CO using pairs of copper wires. So when the customer wanted to make a call, they would either have to turn a crank or click the hook switch to alert the operator. And then the operator would then have to connect that customer's circuit to the other customer's circuit in order to establish the connection. If you've ever watched the Andy Griffith Show, you see Andy pick up the phone, click the hook switch, and tell the operator, Sarah, to get me the diner or get me Floyd's barber. And that's how the manual switchboard worked. Now, initially, boys were hired to work the switchboard because it was believed they had the manual dexterity and mechanical knowledge to be able to connect hundreds of lines per hour. But between the wrestling matches, spitwad wars, jokes, and the foul language that they used with the customers, they were soon replaced by women. The switchboard was automated in 1891 when an undertaker in Kansas City, Missouri, thought that the operators were telling callers his line was busy and they were routing calls to his competitors. So thinking that callers, not operators, should choose who was being called, this undertaker invented the automatic telephone exchange. So that eventually ended the need for switchboard operators, but long-distance operators were still in use well into the late 80s. The COs were eventually connected together, and this formed the PSTN, or the Public Switched Telephone Network. So here you see a telephone and a central office. The telephone is located in a place called the customer premise, and the telephone switch is located in the CO. You've probably heard someone refer to your 911 equipment as customer premise equipment, or CPE, and that just means the telephone equipment at your site. So you can see that the telephone is connected to the CO with two copper wires. And these were called a local loop, sometimes a subscriber loop, or more often just called a loop. So this loop is a dedicated circuit between the customer and the CO, and is what the operators used to have to connect manually. The COs are connected by telephone trunks. When a caller picked up the phone and dialed the telephone number, signaling was done from the loop to the CO and then to the party being called. This is what was known as dial-up, also known as POTS, or plain ordinary telephone service. So if someone asks you if your phones are POTS lines, they're asking if they are plain ordinary phone lines as opposed to being on a VoIP or digital system. Now, once the telephone was invented, the American Bell Telephone Company was established. Over the years, the company expanded, branching off into different phone companies providing service to different areas of the country. These telephone companies were known as LECs, or local exchange carriers, and they were dominated by the Bell Telephone Company. The Telecommunications Act of 1996 was implemented to promote competition between local phone service providers to compete with the Bell Telephone Company. These local providers, and you can see a bunch of them up here, they became known as CLECs, or competing local exchange carriers. They offered lower prices for local and long-distance phone service and cable, and hundreds of these companies popped up everywhere. You'll also hear the term ILEC, or Incumbent Local Exchange Carrier, and this refers to telephone companies that provided local service before the Telecommunications Act of 1996. So let's talk about 911. When 911 was invented in 1968, it was set up for calls to be delivered to a PSAP, a public safety answering point, from a landline or a home or business phone by use of dedicated copper trunks to the 911 switch. A CAMA trunk, or Centralized Automatic Message Accounting Trunk, is a special analog trunk that was originally developed for long-distance billing, but is now used mainly for emergency call services. Most agencies will have at least 2 sets of these trunks coming into the building from different locations to allow for redundancy. This prevents your 911 from going down completely due to your trunks being cut or from some other type of disaster. If you don't know where these trunks terminate at your building, you might want to ask. It's always good to know. Now, with basic 911, only voice was delivered, no data, and it was delivered to a predetermined PSAP. And there are still agencies today that have only basic 911. Now, enhanced 911, or E911, was an upgrade to basic 911 using new databases to gather information to be delivered to the PSAP. E911 brought in Annie-Alley, MSAG, class of service, ESN, and ELT, and allowed for selective routing with the selective router, or tandem. You've probably heard that Annie and Alley are automatic number identification and automatic location identification. So let's talk about what that means. Okay, for billing purposes, the phone company had a database containing all the subscriber phone numbers. In order for E911 to work, the MSAG, or the Master Street Address Guide, had to be developed. The MSAG contains all the addresses residing in a PSAP's jurisdiction, as well as the ESNs and the ESZs, which we will cover in a minute. When a call is placed to 911, it travels to several places to gather information to be presented on the Annie-Alley screen. The caller's voice and Annie travel immediately to the PSAP. While that's happening, the MSAG is being queried to find the address, the ESN, which you see here at the bottom, and the ESZ that correspond to that phone number. This information is then forwarded to the PSAP. Now, because of the importance of the Alley information, most agencies have access to more than one Alley database, and they will generally be geographically diverse. So, for instance, my main Alley database was maintained by a city about 40 miles north of my agency, while the secondary database was in Houston. You may receive a call from time to time from your LEC, local exchange carrier, telling you that one of your alley links is down. And what this means is that one path to your alley database is down, but you still have your secondary link to deliver the alley. Now, while this information was originally maintained with the LEC, the local exchange carrier, there are now third-party companies who provide the alley links. So you might want to find out who your provider is just in case. It never hurts to be prepared. So each address in the MSAG is assigned an ESN, which designates which police, fire, and EMS agencies would respond to calls in that specific geographic area. This geographic area is known as an ESZ, or Emergency Service Zone. So, for instance, and this is a made-up map, this is not true, the normal response for your center, you answer for the city of McKinney, and the normal response for the city of McKinney's jurisdiction would be AMR EMS. But the ESN here is 322. And even though it's part of McKinney's jurisdiction, Billy Bob's EMS responds to that area. The ESN for that address would specify that there is a different response in that emergency service zone and would display it on the anti-alley screen. This information is what's called the ELT, or the English Language Translation. And the ELT is what is used by the CPE, your customer premise equipment, to transfer calls to the correct responder. In this case, McKinney. The alley screen also contains a class of service. You see here, you've got the business class of service that was delivered with the call, and gives information about the type of phone line the caller is calling from, such as residential, business, or coin. And for those of you who weren't here then, coin phones used to be on every street corner, and that was where Superman changed into his super costume. So now let's talk about wireless 911. The car phone, and yes, everybody looked like this using a car phone, was developed in 1946, and it evolved over time, and in 1981, the 1G system was developed. Although some people thought the cell phone was a phase that people would get over, the cellular telephone technology changed and usage exploded in the 90s, causing numerous problems for 911. After years of knowing where the caller was, all of a sudden we didn't have a clue, but the public didn't know that. So about this time was when the answering phrase, 911, what is your emergency, became 911, what is the address of your emergency? Because suddenly we were back at square one, just like having basic 911 again. When a 911 call came in from a cell phone, even with enhanced 911, the call taker didn't have any anti-alley information. So the FCC created deadlines for wireless carriers to deliver the caller's phone number and location information, but it was broken up into two phases. Phase one allowed the phone number of the caller and the location of the cell site and cell sector to be delivered to the PSAP with the call. Now, there were two types of cell towers, omni and directional. The omni cell towers received cell signals equally well from all directions. Directional towers had three sectors, each of which faced a different direction. So In urban areas, a directional tower may cover a different jurisdiction with each of the three sectors. Now, to assist with routing calls, pseudo-ANIs or P-ANIs were created. Essentially, it was a 10-digit number that was assigned to each sector, similar to an ANI, hence the name pseudo-ANI. So when the call was delivered to the PSAP, the caller's phone number, the cell tower location, the sector, and the P-ANI were delivered with the call. You also received a new class of service of MOBL for mobile, WRLS for wireless, or WPH1 for wireless phase 1. Now, with the delivery of cell sector information, if the cell tower location showed 1234 Main Street Southwest, then you knew that the person was hopefully calling from a pie-shaped radius that stretched southwest from 1234 Main Street. So a phase 1 call is delivered to the PSAP with voice and data separately, although you would never know it. While the voice, the P-ANI, and the ANI go through the mobile switching center, or the MSC, and the end office, which is another name for the CO, before going through the selective router to be sent to the PSAP. The data takes a different path because it has to go to the ALI database before being delivered to the PSAP. And the ALI database can be anywhere in the U.S., depending on the wireless carrier. The call may have to travel to Kansas to get the ALI before going back to the PSAP in Florida. And this happens so quickly that you generally won't notice a delay. For phase 2 wireless, it was required that the wireless providers deliver the XY coordinates of a call or the longitude and latitude of the handset to the PSAP. There were 2 types of technology used, and the accuracy requirements from the FCC were different for each of them. Now, in this illustration, you can see the difference between the voice path that goes from the phone to the satellite to the mobile switching center, or from the cell site to the mobile switching center, the selective router, and straight to the PSAP. The data travels a different path completely, going to the satellite, the position determining equipment, or PDE. Then it goes to the mobile positioning center, the MPC, back down to the ALI database to get the information, and then it's delivered to the PSAP. Another database is the call routing database, and that's another database that the call may query before it's delivered. Now, on the handset solution, some carriers used the handset solution in which the handsets were GPS enabled. Some carriers used a network-based solution in which the lat and long of the handset was determined by the signal's TDOA, or time difference of arrival at the cell towers, and the angle of arrival. So when the call is placed, the signal is picked up by 3 cell towers. And based on an algorithm with the time difference and the angle the towers received the signal, the caller's location was determined to be at a particular location. Because the network-based solution wasn't as accurate as the handset-based solution, the accuracy requirements were different. Now with the phase 2, ANI and ALI, you got another class of service, which was WPH2, along with some other elements to indicate how accurate the location determination is. So in addition to the lat long came the uncertainty factor. And the uncertainty factor tells us in meters how accurate the lat long is that was delivered. For example, an uncertainty of 20 would indicate that the caller's location is within a 20 meter radius of the lat long provided. The confidence factor is a percentage, and it tells if the call meets the 67% or the 95% accuracy requirement of the FCC. The confidence factor works with the uncertainty factor, and it won't be delivered without the uncertainty. But let's say that you get a call that has an uncertainty of 20 with a confidence of 95. That means the carrier is 95% certain that the caller is within a 20-meter radius of the lat long provided. Not all carriers provide the confidence and uncertainty, so you may or may not see these in your wireless calls. And you can see in this alley screen, the confidence factor is 68, uncertainty is 9. So they have they're 68% confident that the caller is within 9 meters of this X and Y location. Now, coming up is the Z-axis location, and it's something that the FCC has been working on to improve location information. The Z-axis is the vertical location of the caller. So this would be useful for a wireless caller in a multi-story building who can't give their location for whatever reason. Testing has been done on the technology, and the major wireless providers have been given a deadline of April 3rd, 2021 to deploy it. So it's in the works, but it's not there yet. Now let's talk about VoIP, or Voice over Internet Protocol. And this is another way that 911 calls come in, and they can be another challenge to call takers. So with VoIP, the signal can be carried by a modem, a DSL, T1, or a wired or wireless network that provides connectivity to the internet. So what are DSL and T1? Well, DSL is a digital subscriber line, and it allows you to get a high-speed connection from a telephone wall jack. A T1 is a line that delivers high-speed connections, and it can be channelized into 24 channels. So it can carry 23 calls at one time and have one line for data such as caller ID. So in this illustration of a VoIP call, you see that the 911 caller places the call to 911. The call goes into the internet, to a call router, and to a gateway. And the gateway will send the call to the PSTN, down to the dedicated 911 switch, to the PSAP. Meanwhile, the call also goes through the databases to get the address and send that in to the PSAP. Now, with VoIP calls, even though you don't notice anything different, with the VoIP calls, the caller's voice is digitized and it's converted into small data packets that are sent over the internet and put back together as voice signals at the other end. The data packets don't all arrive at the other end at the same time, but they're all put back together at the same time. So every so often a packet can get lost and won't be included at the end. And this will come across when you're taking a call as maybe a slight hesitation, or it may sound like the phone is cutting out. but it generally does not affect the ability to understand the caller. And this is an illustration of how the calls are put into packets and sent. They have to have headers and footers and everything else so that when they get to the other end of the line and they're put back together, they have to know which packets go together to become that voice signal at the other end. And so this is just an illustration of how the packets are done. And I'm not going to get into the RDP and UDP right now, just because by now I'm sure your head's spinning. So now there are two types of VoIP. There's static and nomadic. Static VoIP can be provided by a cable company to a residence where the telephone doesn't leave the home. The address is provided to 911 just as in a regular 911 call from a landline. Nomadic VoIP is usually a VoIP phone in a portable computer that can be taken with the subscriber. The problem with nomadic VoIP is that the address must be provided by the owner. If the computer is moved, the subscriber has the responsibility to update their address, which oftentimes doesn't happen. So for instance, a caller might move from Texas to New York and forget to update their address. So if they call 911, the call is going to be routed to the address that's registered to that computer, which is in Texas, at their previous address. So that was another challenge with VoIP. And with VoIP, we got another class of service, which is VoIP. Now, most of you have heard of Carey's Law by now, which pertains to the use of MLTS, multi-line telephone systems, or PBXs, private branch exchange. PBX systems have been in use for a long time, and they've had two major challenges, one of which was the requirement of MLTS systems to dial an 8 or a 9 to get an outside line in order to place a call. And this is where Carey's Law came in. It stemmed from an incident in Marshall, Texas, in which a woman named Carrie Hunt Dunn was attacked by her estranged husband. Her daughter, who was 9 years old at the time, tried to call 911 just as she had been taught, but she was unaware that because they were in a hotel, she had to dial 9 to get an outside line. And because her call never went through, her mother died. Afterwards, Carrie's family worked to have a law implemented that required all MLTS systems to allow users to call 911 without having to dial a prefix for an outside line. So your city phone systems or your county phone system should allow you to pick up any of the phones on the PBX, on the city's PBX, and dial 911 without having to dial 9 for an outside line. If you don't know if your system can do this, you need to check it. With phone systems that are in place now, especially with all the VoIP phone systems, fixing it so that it can dial 911 direct without a prefix, such as 8 or 9, is literally something that's done in the back, according to the tech people. Now, I don't know where in the back is or what exactly in the back is, but I know that in the back they can fix that, and it doesn't cost any money. So, another challenge with multi-line telephone systems, or PBXs, has been the issue of businesses with multiple branches being on one PBX. So you'll have a bank, for instance, that has a branch on Texas Street, one on Main Street, and another in Brothertown, 10 miles away. When anyone from one of those branches dials 911, the call will go to the PSAP of the branch where the PBX is located. So if that branch is on Main Street, but the caller is at the branch in the nearby town of Brothertown, the alley is going to show the address of the Main Street branch, and that's it's going to be delivered to the PSAP where Main Street branch is located. The ANI is going to show the main number of the bank, so the call taker won't have a good callback number. And this has proven to be a big problem in the past. So, for instance, years ago I took a bank robbery call that came from a bank in the town I was working in. And I asked the caller if that was where she was. That was first mistake. I should have made her give me the address. But I asked her if that's where she was. She said yes. We sent the officers there, and it turned out that she was actually calling from a branch in another town about 20 miles away. So, needless to say, we did not catch the bank robbers that day. But this was a problem that was first discovered when we first started getting these calls. Now, I know that this may be how you feel after listening to all of this. And trust me, I feel your pain. We tend to go through training, learning how to do the job, and never wondering how all the magic happens. When you find out how much actually goes into delivering these calls, it can make your head spin. One thing to keep in mind, though, is that the more you know, the better able you are to do your job. So don't stop at learning how to do it, but keep trying to find out what makes it possible for you to do your job. Now, unfortunately, this lesson only covered the very tip of the iceberg. I haven't even begun to get into what's coming with NG 911. So you're going to have to stay tuned for episode 2 when we go forward with even more technology that you always wondered about, but were afraid to ask. So this has been a short lesson today, frankly, because I thought this was going to take a whole lot longer to go over. But in the meantime, while you're waiting for episode 2, we want to let you know to join us next month on Wednesday, December 4th at noon Central Time for a presentation by Adam Tim on the 3 keys to beating dispatcher stress. Now, if you're not stressed, there's no point in joining this. If you do have a little bit of stress from your job, then you might want to tune in and listen to Adam tell us how to beat this stress. So, questions? One question we have so far is, can you get copies of the slides? You will get a link. Within 48 hours, you will get a link to a recording of this, and it will include the video and the audio of this. Now, if you have other questions, I'm glad. Thank you for asking that, because I could answer that question. If you have a question that you think I can answer, go ahead and send those in. I'll try to answer. And if it's something that I can't answer, then I'll just disconnect you from the webinar. So if you have questions, send those in. In the meantime, let me let you know, if you need the information on today's lesson for continuing education credits, send an email to info@comelectronics.com. If you want to know more about our recording solution or our third-party quality assurance, send, again, email to info@comelectronics.com. Is there special hardware for the call taker to receive anti-alley information? Yes. Yes and no. So if you're on basic 911, you will not get the anti-alley information. To receive that information, your phone, your CPE needs to be able to deliver that information. And so on basic 911, you're able to receive 10 digits. But your phone company has to upgrade your equipment so that you can receive 20 digits, because to get the anti-alley, not only will you get the caller's number, but you also have to get the P-ante. And to do that, you have to be able to receive both 10-digit numbers. So depending on what equipment you have, what 911 equipment you have, most, if not all, actually all of the phone companies that provide 911 equipment now provide that in their 911 screen. So you can talk to your LEC, your local exchange carrier, and ask them what you have to do to receive that anti-alley information. And thank you for letting me answer one that I could answer, kind of. Okay, do we have any other questions? Is there a list of acronyms? Yes, absolutely. So on the NENA website, it's NENA.org. They have a master glossary. And in fact, I can show you. I have it on my desktop because I still have to use it. So NENA has a master glossary of 911 terminology. I have always kept this on my desktop just so that I could refer back to it when I didn't understand what I was reading. And it's got, there are numerous iterations of it, and so it's going to have pages telling you when it was updated. But it's got everything in here that you could hear about 911, everything coming up in 911. So that's why you want to have that available for you. And it's the NENA Master Glossary. You can Google it and it'll come up. Okay, so why would we need anti-alley in the recorder? Why wouldn't you? So if you're recording your calls because you know they're important enough that you may need to go back and refer to them, the anti-alley is going to be something that you may need to refer to also. If you have for instance, we had a tornado, and probably 2 or 3 months after the tornado, somebody called and said that they had called during the tornado, and they never got through to anybody. And so I was asked, did this person call? Well, the only way for me to find out if the person called that was easy for me to do was to go through my recorder and search based on the anti-alley. She gave the phone number that she called from. I searched the recorder, and I never found that number in there. So if she called 911, she did not get our city. And so if you're going to have complaints about somebody says they called, you can always go in your recorder and check to see whether they called or not. Will you receive a certificate of completion for this class? You can. Just like I said, if you want something, send me an email at info@comelectronics.com and let me know that you want a certificate, and I will send that to you. Can the system override anonymous caller ID? That's a very good question. I don't think so, but I can't swear to that. I'm trying to remember if I ever got any anonymous caller ID. You know what? I honestly, I cannot remember if it can do that or not. I don't think so. Because the alley is generally going to come on a landline phone. The alley is going to come from the phone system, and I think even the blocked numbers come through, or not blocked, but hidden. I can't remember what they call them, but people had their unlisted number. Those when we had listed and unlisted numbers. But if somebody has an unlisted number, because the information comes from the MSAG, that number is going to come through. On cell phones, you know, people can spoof it. On cell phones and VoIP, people can spoof numbers all the time. So generally, that's what you're going to get is whatever is spoofed. So I don't think it will override that. Well, what recorder did I use? Hello, it was Higher Ground. That's what I used. Annie Alley is not necessarily always delivered. There are times when, especially on cell phones, on wireless calls, when you may get a call from an uninitialized phone, which means it's a cell phone that has no service. And because the phone has no service, it's not going to go through a cell carrier's network to get that information. So you may get a call, because cell phones are still allowed to dial 911 whether they have service or not, which we get a lot of those because, you know, people give their kids their cell phones to play with to keep them quiet, but they don't turn them off and they don't take the batteries out. So you'll get these calls that have an area code of 911 and then all zeros. Or there may be some other numbers on there, which would be the serial number of the phone that's being used. So you can get a 911 call in which you don't have any Annie Alley, but it will show on the Annie Alley screen that you have nothing. So that's a good thing. So anything else? Okay. Well, I want to thank everyone for asking questions that I could answer for the most part. And I want to thank all of you for joining us. This presentation has been made possible by Commercial Electronics, provider of public safety solutions, including the Higher Ground Next Generation 911 Recording, CQIP Third-Party Quality Assurance, and Carbine 911 Next Generation Call Handling Platform. If you have any other questions, you can send them to me at info. And yes, you will get a copy of this as long as you were registered. So if you have any other questions, again, send them to info@comelectronics.com, and I will answer anything else you need. So thank you, and y'all have a great day.